That one's actually not a checkpoint. I have a different one that is the checkpoint. It looks eerily similar. I mean, like, super similar. Hold on. I got my life not together. Oh, I have my life together. Good. Okay. Let's get going. So we talked about this yesterday. Were there any questions about this? What an exponential function is, why it's different than a linear function, why the graph looks different. Okay, well then you're already ahead of third because they only did this today. We talked a little bit about yesterday about how this graph is being made, but that's what I want to focus on today. Today I want to focus on how we make an exponential graph. We've already done some of it with our string theory and our zombies. So let's talk about our string theory. I think we talked about it yesterday, but it can't hurt to talk again today. Why does my graph get closer and closer to 0 but never actually reach 0?
Because there's always
going to be some string left. It doesn't matter how many tiny pieces of string you have, there's always going to be a little string left. Okay, but in real world, like thinking exponents-wise, if I'm going to the left, I'm having a negative x value, I'm having a negative exponent, that's why I'm ending up getting something that's a really tiny decimal. I'm going to say all that again in a moment. Okay, and then when we were having the zombies, some people hurt my feelings, and I'll let you fix that today as well. So let's talk about what we're going to do today. I'm going to work 2 problems. That's it. Then you're going to have 2 more problems. Sounds easy. Fine. I need those 2 problems before you leave the room. That would be our goal. If you don't finish those, that would be your homework. After that, I need you, unless you're, I told you specifically, they got bonus on me on that zombie exit slip. Otherwise, I need you to either, I know Maggie and Shanti, they don't have a zombie exit slip. I need them to have one, and I need everyone else to fix theirs. Because some people said, for instance, that the linear strain would take less time to infect people. The linear strain is going at a slower rate. Once the exponential takes off, it's going to win. So let me recap what we did so those who weren't here for the zombie activity can kind of understand. So you had the string activity. The zombie was like, let's say Jameson's the head zombie. If it's linear, he kills off, let's say, 4 people. He kills off this whole table. They're dead. And then he goes and he attacks Will's table and Maddie. They're dead. Then he attacks, this table over here. They're dead. But he's done that every single day, and that's 3 days worth. You see, we still have 2 tables pretty left. So, yes, he was attacking a lot of people. But since he was the only one attacking, it was taking a longer amount of time. If, let's say, he attacks just Zach, he only attacks 1 person. But the next day, both zombies get to attack. So both of them attack those 2, and then the next day, all 4 attack those 4, and then now I have 8, and those 8 attacking the other 8, and then all of a sudden the room's out. We're going to be out much, much faster if we're growing at an exponential rate. And I had some people write that beautifully, and their equation was ugh, or they had an equation, and their writing was beautiful. I only had 2 people who had beautiful answers, and I already told them they got bonus. So if that's not you, and I haven't told you that, then when I hand it back, you need to fix it, because something was not perfect about it, and you would like a perfect score. Where do I put checkpoints? What category? I put them in the 30. And as you know, I make you do them until you get them right. So you'd really like for me to not hand the zombie thing back to you for another time. Because Lord knows you're probably talking about zombies after today. Okay. So I'm going to do, it says on the checkpoint that we need to create a table as well as a graph. So I'm going to make my table on my own paper. If you want to do it on the back, that's fine. I just can't flip back and forth and everyone's following me all day. That's not going to work for me. So it says to make a table in a graph. There are 2 equations. Which equation is exponential growth and which equation is exponential decay? A is growth. B is decay. You can tell because if it's a fraction, it's going to be decay. Okay, our graphs are going to look that way. Growth looks like a flower that's growing. It's getting big and beautiful. Decay looks like a flower that's dead, and you should probably pick it and throw it away. Okay, so we need to make a table. For A, I've got f of x equals 3 raised to the x. We know f of x and y are really the same thing. I need to pick some values for my table. What kind of things do I need to make sure end up in my table? What kind of x values should I pick?
I don't know. Never mind.
What kind of numbers do you normally pick for a table? Well, we need 0 to be on there. Who else do we need to be on there?
1.
Well, we need a couple positive numbers. What else do we need? I'm giving it away. We need a couple positive numbers. We need some negatives. So I'm going to go, because I feel like it, from -3 to 3. If you want to do -5 to 5 or whatever, you can. I'm just trying to pick a good range of values. A couple negatives, a couple positives, and of course my favorite, 0. Now if we had a linear function and it said f of x equals 2x plus y, if I had that and I asked for f at 7, what would you tell me to do? Everywhere you see an x, put a 7. We're going to do the exact same thing with our table with exponential functions. So everywhere I see an x, I'm going to put a -3. So it's going to be 3 raised to the -3. Let me zoom in a little more. It's going to be 3 raised to the -3. Can I leave my exponent like that? So what does it become? What do we do to the negative exponent? We do put it in the denominator and we punish it. So it's 1/3 to the 3rd. What is 3 to the 3rd? 1/27. And I need someone to type that in the calculator because I don't know where to put that point on my graph. I need an actual decimal. So 1/27 is what?
It's 0.03.
0.03. Okay. Are there any questions about that line?
Why do you need it to be a fraction? I mean, I guess.
I don't know how to graph a fraction. I mean, I know how to go like 1 1/2, but like to go 1/27, I don't know how to do that. So I need a decimal. It helps me when I'm graphing better. Okay, so I'm going to do the exact same thing with the -2. 3 to the -2, that's 1/3 squared. So it's 1/9. I need that decimal. 0.1. Okay, we started off super tiny, really close to 0. We're growing a little. Let's see if we grow even more. So if I plug in a -1, I have 3 to the -1, which is 1/3 to the 1, which is just 1/3. I need to know that decimal. That is 0.33. Oh, look, I'm getting even bigger. Okay, and then we get to my favorite. I plug in a 0. What is 3 to the 0 power? Anything to the 0 power is 1. More than one person in the room missed the question on the test that asked about raising to the 0 power. How do you miss my favorite question? You knew I was going to put it on there. I told you I was going to put 1 on there. Okay, I'm going to let it go. Okay, I need to do 3 to the 1st, which is just 3. 3 to the 2nd, which is just 9. And then 3 to the 3rd, which is 27. Let's face it, I'm about to graph this on a really tiny graph. It's unlikely that I'm going to be able to fit the point 327 on my graph. Some of these I might not be able to graph. I'm just trying to give myself some options. Are there any questions about my table? Does anyone need help with the table? Okay, again, I know this is exponential growth because look at the table. It started off small and then it started getting huge. 1, 3, 9, 27. Like, it's going really big, really fast. The next one would be 3 to the 4th, which is 81. Like, it's getting huge. Okay, over to my graph. I'm going to put a big X and Y coordinate plane in the middle of that graph grid. I'm going to graph both examples on the same coordinate plane, possibly because I'm lazy, partly because I want you to notice they overlap a bit. Okay, so I'm going to do the first one in blue. So if I look back at my table, that's what I'm going to use to figure out my points. So for instance, I have 0, 1, and 1, 3. So I'm going to plot those points. 0, 1, 1, 3. My next one says 2, 9. Well, I can go over 2, but 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just guessing. 9's somewhere up there, and I'm just guessing, and that's never good, but I'm a guess anyway. I get that 9 doesn't fit on our plane. So there's no way I can do 3, 27. There are not 27 boxes up for me to count. So I'm stuck on that side. I'm going to have to go to the negatives. Okay, so -1. Yes, dear.
You put the things.
I did 0, 1, 1, 3, 2, 9.
Okay.
I'm using my points from my table. Okay. So I go to -1, and we typed it. We did that decimal as 0.33, so it's a little below a half. Am I really being that picky? No. But the next one's a little closer to that 0, and the next one's even closer. But like we talked about with the string activity, we're never actually going to hit the graph because we're never going to have no string. Okay, I can connect my dots as best I can. I have this curve, and it's obviously growing up. It looks like a flower that's happy. It's exponential growth. Are there any questions about this one? Again, I plotted the points from my graph, so let's see. I did 0, 1, 1, 3, 2, 9. We talked about 3, 27 wouldn't fit, so I couldn't do that one. I did those 3, 0.3, 0.1, 0.03. Are there any questions about how I got the points? Okay. Let's move on. So the second one I'm going to do in red. Now, a good question would be, do I have to make a table, Ms. Compton? I know my exponents. Do I have to make a table? You probably don't for a growth. I mean, should you? Because the directions say to do so, and you're going to follow my directions, and you're a good student? Yes. Do you absolutely have to in your mind of minds? No. Probably not for growth. For decay, yes, because the darn fractions start getting confusing. Okay, so B says f of x equals 1/4 to the x. So I need another table. I'm going to use the exact same values. -3, -2, -1, 0, 1, 2, 3. Since it's decay, I need it to start dying, meaning I need it down here to start getting closer and closer to 0. Where with the others, it was with the negatives we were closer and closer to 0. Okay, so I'm going to show you this first one. Everywhere I see an x, I'm going to put a -3. So I have 1/4 to the -3. Okay. If I were you, and I were just trying to make my mind easy today, and I was lazy, I would just type this into my calculator. If I was wanting to have an easy day, and I really didn't want to overthink math, I would just type that into my calculator. When you type it into your calculator, what do you end up getting? You get 64. Now, if you really want to know why on earth a fraction raised to the -3rd ends up being 64, I will show you. But I swear I will not know whether or not Jacqueline just spends the rest of her day asking her calculator. I'm not going to know if she's actually practicing rules of exponents or not. So it says 1/4 to the -3rd. You know we punish it, so it's 1/1/4 to the 3rd. Okay, 1/1/4 to the 3rd is 1/1 to the 3rd is 1. 4 to the 3rd is 64. So it's 1 And if I wrote it again in a different way, it's 1 divided by 1 over 64. My teacher always said, flip the second multiply. I'm not really sure that's good math, but I'll say it now. Flip the second multiply. It's really 1 times 64 over 1, which is just positive 64. Sounds crazy, but it's true. It doesn't hurt my feelings having to spend the rest of the day typing it into his calculator rather than debating his rules of exponents. Okay, so you typed the next one down in your calculator already because you weren't really listening. What was it? 16. And then the next one. And then, of course, everyone knows this one. If I raise 1/4 to the 0, what do I get? I get 1. So it started off big, 64, 16, 4, 1. We're getting smaller. We're hoping it's going to keep getting smaller. So let's see. 1/4 raised to the 1 really is 1/4, which is 0.25. One-4 squared ends up being 1 over 16, which is, I need the decimal. That sounds great. I know it's like 6125, but I can't graph that particularly. I'm not that good. And then 1/4 to the 3rd. It's 1 over 64, which is some other decimal that must be super duper tiny. That is for sure.
Oh, you want it?
I would like it.
Okay. 0.012.
0.02?
Yeah.
Because it's 125 whatever, or 15 something, 15625. Okay, that's fine. Let's face it, when I start getting 0.06, 0.02, I'm just trying to get as close to 0 as I can without actually touching it. Okay, so I'm going to graph it, and then it's going to be your turn, and I'm going to be done talking. So, let's see. I know one of my points is, I'll pull my little sheet over. 0, 1 was a point, so 0, 1. 1.25, so 1 up just a little bit, 1.25. 2, 0.06, 0.06 and 0.02. I'm just getting as close to 0 as I can without actually touching that line. And then for the others, negative 1/4, so negative 1 up 1, 2, 3, 4. Negative 2, 16. Let's face it, I'm never going to reach it. It's going to be somewhere high up there. I can't make it fit. So I'm done. Because if I can fit negative 2, 16, there's no way I can fit negative 3, 64. So I'm just going to call it quits there. If I connect my dots, turn my paper a second in at my dots. I get closer and closer to 0. And they look really similar. One is dying really fast, one is growing really fast. Growth and decay look very similar. What point do they have in common? 0, 1. Notice both their intercepts are at 0, 1, which is what you were in trouble for yesterday because you just assumed all graphs would go through 0, 0, when all exponential graphs, their first point is 0, 1. So if we move up 2, our next point would be 0, 3 because we have to move 0, 1 up 2. Oh, I digress. If you got that and you know what you're doing, great. Here's the checkpoint. It's only 2 questions. When you get it done, as long as you're being quiet, I won't bother you. I would make sure I got my zombie thing done well, though. Did I pat that back? Probably not. I need to. 3, 4, 5. Jameson, I've gone to these 2 tables. Go to the other table for me. Thank you, dear. Here. Yeah. That's fine. Riley, here's your zombie. Kennedy, here's your zombie. I see that. You're not going to be. You're Ryan. You're welcome. You don't have a zombie? Who doesn't? Just you 3?